Hi everyone, I'm Priya, Technical Marketing Engineer from the Aruba Switching Business Unit. And in this session, I'll walk you through the next update, that is ZTP support or OOBM with IPv6. So let's dive into the session. So here's the usual agenda for the ZTP over IPv6 session. I'll take you through the overview, use cases, a little bit of details and caveats, and how it's configured, both on the switch and the DHCP console. We'll also take a look at the troubleshooting and a quick recorded demo. So zero-touch provisioning or ZTP streamlines the deployment of switches by automating their initial configuration. And this is just right out of the box. So when a factory default switch is powered on, ZTP automatically provisions it by downloading and installing the necessary firmware, config file, or both. So let's break this process into two. So the first part is the provisioning part, which involves installing the correct images, config file, and optional onboarding parameters. And the next part is the zero-touch process, which ensures a fully automated and efficient day zero deployment. So let's see what is new in ZTP. And here I have drawn a comparison before 10.15 and after 10.15. So before 10.15, this feature was supported exclusively on IPv4, including both out-of-band management OOBM and in-band management VLANs. However, from 10.15, this now includes support for IPv4 and IPv6, whereas IPv4 has in-band and OOBM, and IPv6 is supported on OOBM only. So this enhancement ensures greater flexibility and compatibility for modern networks, and particularly in environments transitioning to IPv6 for, let's say, management purposes. So let's talk about how ZTP prioritization works in the CX switches. So in this slide, I'll be focusing on both IPv4 and IPv6 scenarios for both OOBM and data ports. So as you see on the left, the highest priority is given to ZTP IPv4 options received via the OOBM port, followed by ZTP IPv4 received in the in-band management VLAN. The in-band VLAN. And the lowest priority is given to ZTP IPv6 options received over OOBM. So we currently don't have any support for IPv6 on data ports. So let's imagine a scenario where if IPv4 is detected on in-band ports first, so the switch waits for 30 seconds to check for any ZTP IPv4 options on the OOBM before proceeding, because OOBM IPv4 is always given the highest priority. So this 30-second time frame is fixed and cannot be configured. So if both IPv4 and IPv6 DHCP servers are active, then IPv4 takes precedence. So when IPv6 options are received on the OOBM, the switch applies the same 30-second waiting logic to ensure no higher priority IPv4 options are available. And one important point to note here is that ZTP does not specify retries. Instead, the process is governed by a 30-second constraint for detecting the higher priority ZTP options. So let's have a quick look at the prerequisites for ZTP. So the switch must run the factory default config for ZTP to activate. So any pre-existing startup or running configuration disables ZTP automatically. So that is to be taken care of. The config file should be a text file or a JSON file on the switch. So ZTP begins automatically upon the switch boot up when prerequisites are met. So no CLI commands are required to initiate the ZTP process. And we have to make sure that the DHCP server must be configured to send specific options. So in this case, it will be the DHCP IPv6 server. So TFTP or HTTP server where the configuration file is stored must be reachable via the OOBM network, as we'll be doing ZTP on the OOBM in this enhancement. And one last thing is to verify the OOBM subnet connectivity to ensure the switch can communicate with the necessary servers. So with that, let's also talk about the platform support. So here are the supported platforms for ZTP on OOBM with IPv6. We don't have support for 4100i, 6000 and 6100 due to the lack of OOBM ports. So let's look at the use cases for this feature. ZTP allows the deployment of thousands of switches at once. So this makes it ideal for large-scale enterprises or branch networks. And it also ensures seamless scaling while maintaining the network consistency. You can configure new devices that can be automatically provisioned upon powering up, and it eliminates the need for any manual intervention, accelerating the deployment timelines. One other important use case is it ensures consistent configuration across devices, thus reducing any errors. Routine tasks like VLAN assignments, port settings, or device onboarding are handled automatically, and this frees up IT resources for any strategic tasks. And the last one is that it pushes updates quickly across multiple devices simultaneously. So the next use case would be native IPv6 networks and dual stack capability. So deploying a native IPv6 only network eliminates the need for NAT. So here we in turn reduce complexity and latency in the network, thus improving the time application performance. That's the real-time application performance. So adding on, IPv6 offers enhanced security features such as built-in IPsec, ensuring better end-to-end encryption and authentication compared to IPv4. And the major use case that I would like to highlight is the dual stack capability. So IPv6 and IPv4 can coexist in a dual stack configuration as shown to your left. So how does this help? So this enables a smoother transition from IPv4 to IPv6 for those looking to migrate. And finally, let's talk about the scalability through IPv6. So the vast address space of IPv6 allows for assignment of unique IP addresses to the devices in a network. So which is particularly useful in large-scale retails and education verticals. So let's look into the step-by-step ZTP process with IPv6. So the switch boots with a default config, and then a DHCP discovery is sent from the management port. Following this is the DHCP offer containing the necessary options from the DHCP server that are sent back to the switch. So this DHCP offer message includes vendor-specific information and the names of configuration and image file that the device needs. So the device uses provided information, that is the switch uses the provided information to connect to the TFTP or HTTP server and downloads the specific image files followed by the config file. And then the switch reboots to download an image file if the version on the switch is different. If not, it continues with the process without any reboot. And finally, the device completes its initialization using the new configuration and firmware, becoming fully operational. So let's look at the key DHCP IPv6 options that needs to be configured for this feature. So the first option is DHCP option 16, and this is used to specify the vendor class identifier to inform the DHCP server about the type of device that is requesting for provisioning. And followed by option 59. So this is one most important option that has to be provided, and it provides the IPv6 address of the TFTP or HTTP server where the configuration and image files are stored. Followed by the option 17. So this option has two sub options, 144 and 145. So 144 specifies the name of the configuration file and 145 specifies the image file. So let's say if a switch receives the DHCPv6 address, but no options for auto provisioning. Example, there's no information about the config or image file. ZTP will wait for an additional minute before entering a failed state. So this allows some leeway for delayed server responses. And in case you have a DHCP relay configured in your setup, no additional configurations are required in it. So here are a few caveats. There are currently no equivalents for IPv6 for the below options supported in IPv4. So the first is central FQDN and followed by the alternate central FQDN or the IPv6 address and the HTTP proxy FQDN or the equivalent IPv6 address. So no central support, MIB or REST API support is offered for this feature at the moment. And as already highlighted, ZTPv6 on in-band ports or VLAN SPI is not supported yet. We also do not support ZTP IPv6 on enhanced secure mode, as we'll have to log into the switch to change it to standard mode, which will contradict the concept of ZTP. So let's move to the configuration part. So I'd like to take you through the DHCP server configuration steps here. We'll also be looking at it in the demo. So the first step is to view the vendor class identifier in the switch. So here is the CLI that you use. So show DHCP client vendor class identifier, which gives you the details about the switch. And this is just a sample config, and you can choose your own TFTP or DHCP server. I'm using the Windows DHCP server console for this. So under the IPv6 scope, I define the vendor classes and enter my switch details here. So once the switch details are added as shown in the left, you can add the display name, its description, and the vendor ID. So I have mentioned the vendor ID for Aruba here in the bottom of the slide. So once all these details are entered, the screenshot on your right shows that there are two other fields, that is ID and binary, which are auto-populated. So you'll just have to enter the display name, description, and the ASCII. And once all this is done, you'll find these two details being auto-populated. So the next step is configuring the IPv6 address of the TFTP server using option 59. So I have two methods here, either configure them through PowerShell or through GUI. So through the PowerShell, I have used the above commands that you can refer to, and I've also mentioned my TFTP IPv6 address, where I have my config and the image file. And you can follow the below steps to do the same on GUI as well. And kindly refer to this link for more details on configuring it through the GUI. So the next step is to define the predefined options. So here under the IPv6 scope, I'm trying to set the predefined options for my device that I've added. So it is a 6200F that I'm trying to do a zero-touch provision with. So once I do that, I will be adding both my config file and the image file sub-options. So here is an example of how I add my configuration file with the sub-option 144, and I describe it as the file name of the config file on the server, and followed by the image file 145 sub-option. So once all this process is done, under the scope options, you have to enable both config file and image file for that particular device. So I'm trying to enable the config file here, and my string value, that is the name of the config file that I have on my TFTP server, is this 6200 ZTP config. I'm also going ahead and checking if this is enabled, and you will see that the config file scope has been enabled and it comes up here as 144. And I also do the same for my image file. So this is the image that I'm trying to load. So let's look at the troubleshooting for this feature. So show ZTP information is a command that can be of help to check the statuses of the TFTP server, its IP, and the image file, the config file details, followed by the central location and alternative central locations. So for now, we don't have support for this, but whereas the first half of the screenshot shows you all the information about the server and the files and their status. So next is ZTP force provision. So this command starts on-demand ZTP. So the DHCP options received are processed independent of the current state of configuration of the switch. And previous ZTP options of the TFTP, HTTP server, image file, and config file are cleared once this command is issued. And you can see that new DHCP requests are sent from the switch. If ZTP fails when the zero provisioning is enabled, then there will not be any automatic retries. And if you have to retry the process again, you should be able to disable and then enable the ZTP force provision command again. So that will help clear the current ZTP state and then send new DHCP requests again. There is no diagram support for ZTP process. So here are a few list of event IDs, severities, and the respective messages for ZTP IPv6 happening in the switch. So there's more event IDs here, continued, and followed by the debug logs and the respective severity and message. So you can refer to this as well. So finally, I have a demo which is recorded, which I'll quickly take you through. So here I have a factory default switch. And so once I log in into the 6200, I'll make sure that I get the vendor class identifier details from the switch as discussed in the config part earlier. I do not have any previous configurations on the switch and it's clean. So next we'll walk through the DHCP server process and how to configure it. So under the IPv6 scope, I'll be defining my vendor classes for the respective switch model, that is my 6200F. So you can get into the edit options and add the ASCII values as well as the description and the display name. So once both of these are added along with the vendor ID, you can see that both ID and the binary fields are auto-populated. So the next step would be adding option 59. So where I'm trying to define the IPv6 address of my TFTP or HTTP server here. So once I define the option 59, So I have done this on PowerShell. So once I do that, you can go and enable the sub options 144 and 145 as well, which is under option 17. So again, we'll have to get into the predefined options. So I'm going to the device of my choice, which is the 6200F. So here I have both config file and image file added already. So I'll show how I did that. So I just got into the edit option to add the config file along with the option and the description. And I also followed the same process and added my image file as well. So that's sub option 145. So once this is done, I made sure to enable the scope options, that is, enable both 144 and 145. So you can see both config file and the image file are listed here for my 6200F switch. And that's the string value that I passed for both the options. So now let's move back to the switch and check the ZTP status. So I'm using the show ZTP information command. So this usually takes like a couple of minutes to come up, but it should be faster. So you can see that the status is in progress and the image download and verification are in progress as well. So the first one to be updated is the config file followed by the image file. And now you can see that the image file is updated as well. So in case the current image file doesn't match the one from the DHCP server, the switch will go for a reboot. And if not, it will continue as is. And you can see that the ZTP status is successful. I have also shown the show interface management command so that the IPv6 addresses are also received on the OOBM. And you can see that the IPv6 address has been assigned to this device. And the status is successful and the address mode is DHCP as well. So that's with the demo. Thank you, and please make sure to scan this QR code to join our Airheads community if you've not done yet.